Hello students, welcome to 60 out of 60 in KCET Chemistry 2025 series in just 200 days. So today we'll be completing the amines chapter. So today will be the last lecture for the amines chapter, and in today's class we are going to discuss about diazonium salts, that is their preparation, physical properties and chemical reactions. Okay, so with this video or with this lecture we will be going to cover all the four big important organic chapters, right? So today will be the last lecture for that. In the next class we'll be doing biomolecules. So I want every one of you to sit with a notebook and a pen, as I tell you in every class, so that you can make notes and you can make important flow charts. So my most of the lectures will only consist of flow charts and the hierarchy list, so please make that so that it will be very useful for you while revising. Okay, so now one more request, please join our WhatsApp channel. The link of the WhatsApp channel will be there in the description section of this video, so that will be really helpful for you to get access to these notes in the PDF format. You will also be able to get the mock test question paper, solutions, everything will be available in our WhatsApp channel. So please do not forget to join our WhatsApp channel. Okay, so now let's get started without any further delay. And in today's class, as I told you, we'll be discussing diazonium salts. Okay, so this is, I think you might have remembered by this now, in every class we do this. So with three parts we have done this chapter already. So in the first part we discussed about the structure, classification, nomenclature and preparation. In topic 2, that is in part 2, we discuss physical properties and chemical reactions, and today's class, that is in part 3, we'll be talking about diazonium salts, its preparation, physical properties and chemical reactions. Okay, so now year wise weightage, you can easily expect 2 to 3 questions from this chapter. Okay, next today's lecture, preparation, physical properties and chemical properties. Okay, so now coming to the first thing, that is the preparation. So preparation is very easy, only one method of preparation is there. So first we take aniline, okay, and we treat it with NaNO2 and HCl. Okay, so this NaNO2 and HCl can also be written as HNO2. So in exam it may be asked in the form of HNO2 or it can be asked in the form of NaNO2 plus HCl. Okay, and this is nothing but your nitrous acid. Okay, so this NH2 groups in presence of this one converts to something called as benzene diazonium chloride. Benzene diazonium chloride. Okay, so how does it look? The structure is like this. You have benzene ring, and then you have on the benzene ring we have N, triple bond N, here there is a plus and Cl minus. Okay, benzene diazonium chloride. So just remember, simple, you have to take aniline and the reagent is nitrous acid. It can be represented in the form of HNO2 or can also be written as NaNO2 plus HCl. Okay, after that we'll get this most important compound, that is benzene diazonium chloride. Okay, so this is all about preparation. Next, coming to the physical properties. So physical properties, it is a colorless crystalline solid and it is soluble in water. Okay, so now coming to the most important thing, that is the chemical reactions. So under chemical reactions we have two categories. Okay, first is the reaction involving the displacement of N2 group, means in that reaction N2 will not be there, like in the final product N2 will be displaced. Next we have coupling reactions. Okay, now under reactions involving displacement of N2, here we have replacement by Cl minus or Cn minus, replacement by I minus, replacement by F minus, chlorine, fluorine, iodine. Then you have replacement by H, then you have replacement by OH, and then replacement by NO2 group. Okay, so that means what we are saying, that replacement, that means, see, if you see the structure of benzene diazonium chloride, it is like this, N2 plus Cl minus. So now what happens, this Cl minus already is not a part of the ring, right? It is present in the form of salt. So replacement by Cl minus and Cn minus means in this part N2 will go and we will get Cl or we will get Cn, we can get fluorine, we can get iodine, then we can get H, then we can get OH, right? So these are the different things that we are going to do, that what reagents are required to replace this N2 group. okay, to replace this N2 group with these groups. Okay, suppose for example I want to add Cl minus, I want to add Cl here, what has to be the reagent required? So that is what we are going to study. So we have 6 type of replacements, right? Replacement of Cl minus, replacement by Cl minus or Cn minus, replacement by F minus, replacement by I minus. 3 completed. Then you have replacement by H, replacement by OH, and then last one is replacement by NO2 group. Okay, so now we'll see these reactions. Okay, so this is your benzene diazonium chloride, and the first thing is replacement by Cl minus or Cn minus. So that is your first reaction, replacement by Cl minus or Cn minus. Okay, so now if you see here, now you can use CuCl2 and HCl. You can use CuCl2 HCl, so that will give you like chlorobenzene. Okay, the product is like this, chlorobenzene. So you can see this N2 is replaced with chlorine group now. Now you can use Cu2Br2 in presence of HBr, Cu2Br2 and HBr. So this will give you bromobenzene, right? You can use CuCN, KCN, and this one will give you cyanobenzene. Okay, so these are the products formed. Now this particular, if you use Cu2Cl2, Cu2Br2, okay, this type if you are using, these reactions are called as your Sandmeyer reaction. Okay, Sandmeyer reaction. Now you can do replacement by chlorine by using different reagents also, that is CuHCl and CuHBr. So this one will again give you chlorobenzene, this one will give you bromobenzene. Now if you use only CuHCl and CuBr, like what is the difference here? Here you use copper chloride HCl, copper bromide HBr. Here only copper HCl, copper HBr. So these type of reactions are called as your Gattermann reaction. Okay, Gattermann reaction. Okay, so this two is your, this first one replacement by Cl minus and Cn minus, clear. For Cl minus what we can use? Cu2Cl2 HCl or CuHCl. For bromination what you can use? Cu2Br2 HBr or CuHBr. Then for cyanide what you can use? CuCN, KCN. Okay, second is replacement by for chlorine over, next one was your fluorine, okay, or iodine. So second one is replacement by iodine, replacement by iodine, right? So what you have to do, simple, very easy, just treat it with Ki. So I will replace here and everything will go here and we'll get iodobenzene here. Okay, so for replacement by iodine we need Ki. The third one is replacement by fluorine. So I'll write like this, replacement by fluorine minus, F minus. So here this is little complicated. First you need to treat it with HBF4. Okay, here what is the sign? H plus and BF4 minus. Okay, so N2 plus will take your BF4 minus. So what we will get? A salt where N2 plus and BF4 minus is present. Now after you heat this, okay, after you heat this, this N2 plus will go and we will get ARF, that is fluorine will come here, N2 will evaporate, and from this one fluorine is taken and there is remaining now BF3. So we will get here fluorobenzene. Okay, so what is the reagent here? This is little complicated. HBF4 you have to use. After that you have to simply heat it. So we'll get first a salt, then after you heat it we'll get AR and F will come, N2 will be a byproduct and BF3 will be another byproduct. Clear? So done. Now replacement by chlorine, replacement by iodine, replacement by fluorine. Next was replacement by hydrogen, right? So next we have here, so fourth one here, that is replacement by hydrogen. So for that you just need to use H3PO2 in presence of water. For replacement by hydrogen we have to use H3PO2 in presence of water. So H3PO2 and water will give you ARH. Okay. Next, fifth one is replace. Okay, so another way also is there how we can replace with by H by using treating alcohol, ethyl alcohol. Okay, so H3PO2 water you can use either this one or you can treat it with ethyl alcohol. So this one will also give you ARH. Okay, Next, coming to the fifth one, that is replacement by OH group, right? So fifth one we have here, replacement by OH group. So let us revise once again. For chlorine we has Cu2Cl2HCl or CuHCl. For bromine you have Cu2Br2 and HBr or CuHBr. For Cn- you have CuCN KCN. For iodine, second one, replacement by I-, you have to simply use Ki. For replacement by fluorine you have to use HbF4 and then you have to heat it. For replacement with H, that is you have to just replace it with H. For that you have the reagent. First one is H3PO2 and water, and another reagent that you can use is ethyl alcohol. Now fifth one we are talking about, that is your replacement by OH-, right? For that again you have to use simply, very simple, you have to just use water. Okay, so this is replacement by OH, so you have to just use water. Next, coming to replacement by nitro group. Okay, this is again little complicated here. So sixth one is replacement by NO2 group. So here first you treat it with HbF4. So this we have already seen here. What will happen? N2 plus will, this is H plus BF4 minus. So N2 plus will take BF4 minus and will get a salt. Now after this you treat it with NaNO2 and copper. NaNO2 and copper and then heat it. Treat it with sodium nitrite and copper, then heat it. So what we will get? We will simply remove everything and we will get NO2 here. Okay, so everything will be removed and we will get NO2. So for NO2 what you have to do? First you have to treat it with HbF4, then you have to use it sodium nitrite and copper, NaNO2 with copper. Okay, so this will give you nitro group. Okay, so this is the sixth one. All the 6 reactions we have done. So now, as I told you, every time we need to do a small revision here. Okay, so quickly tell me the reactions or reagents for different replacements. Replacement by Cl- or Cn-. For Cl- what all things are there? See, I'll write it like this. For Cl- we can use Cu2Cl2HCl or we can use CuHCl. Okay, for replacement by Br-, Cu2Br2 HBr, right? Or you can use CuHBr. Okay, then by Cn- if you want, we need CuCN KCN, right? This is done. Now for I-, what is required for replacement with I-? We just simply need Ki. Okay, now this one for F-, what we need? We just need first HbF4. Okay, after that we need to heat it. For replacement by H we have 2 things. First thing is H3PO2 and then water, or you can directly use ethyl alcohol. For OH simply you have to use H2O directly. For NO2 first you have to treat it with HbF4. Okay, after that you have to treat it with sodium nitrite, NaNO2 in presence of copper, right? All the replacements are clear. 6 replacements are there. Chlorine, bromine, cyanide, that is first category. Then you have iodine, then you have fluorine, H, OH, nitro group. Okay, now we'll go to discuss about the coupling reactions. So coupling reactions means what? This, in the previous reactions, if you see, this N2 group was vanishing, right? In the product there was no N2 group. In coupling reactions this N2 group will be there. So the first of benzene diazonium chloride plus phenol group. Okay, if you treat it with phenol, what will happen? This HCl will vanish or HCl will come out. So what will happen? We will get this benzene ring, then this is your azo bond, this part is called as azo, and then whatever left is present on this side. So this is called as para-hydroxy, okay, para-hydroxyazobenzene. Okay, para-hydroxyazobenzene. Now the color of this compound is very important, that you should remember, it is orange in color, para-hydroxyazobenzene. Now you can also react this one with aniline. Coupling reaction can also take place with aniline. So here what will happen? This HCl will be removed, then we will get here azo group. This is your azo group. To that we have NH2 group. So what will I get here? Para-amino azobenzene, and this is yellow in color. Okay, the this dye is yellow in color. So we have two coupling reactions, one is with phenol and one is with aniline. So with phenol we will get para hydroxyazobenzene, it is orange in color, and with aniline we will get para aminoazobenzene, which is yellow in color. Okay. So students, that's all benzene diazonium chloride reactions we have done. Now quickly we will practice the questions from here, and then we'll end this lecture with a very good note, where today we'll be happy that we have completed the amines chapter. Okay. So this was a homework question that I gave you. An aromatic compound A, C7H9N, on reacting with NaNO2HCl at 0 degrees Celsius forms benzyl alcohol. So if you know what is benzyl alcohol structure is like this. So that means this is a primary alcohol. That means what you can suggest, that whatever is the means it must be produced from a primary amine. So what can be the product here? It must be CH2NH2. Okay. So we have discussed when primary amines are treated with NaNO2HCl, right? Primary amines are treated with NaNO2HCl, that gets converted to primary alcohols. Okay. So now the question is arising, the number of isomers possible for A. So we have got now A. Now we have to find the number of possible isomers. So this is first isomer, we can say. Now I can do what? I can just take out CH3 from the chain and can keep it in the ring, right? So I'll write like this, NH2 CH3. This is second. Now you can replace this, change the positions of CH3, ortho para meta will get. So I'll get like this, NH2 and CH2, meta one, sorry, CH3. And the fourth one I can get is like this, where I have NH2 and in the para position I have CH3. Now the fifth one can be, see, we can make it a secondary amine also. So you have like this, N, H and CH3, right? So now if you see total how many isomers we can get? We can get 5 isomers. So correct answer for this question will be option number 5. Okay. Fine. Next, coming to today's question, the correct sequence of reactions to convert para-nitrophenol into quinol. Okay. So para-nitrophenol is there like this. First let us draw para-nitrophenol to quinol. So what is the structure of quinol? You must be knowing, it is OH, OH. Okay. So now how to convert this one? The first option, if you see, reduction of which one? NO2 will get reduced. So if I do reduction, we will get this one, that is OH and NH2, sorry, NH2. Next you have done diazotization. Diazotization means converting it to N2 plus and Cl minus. So we'll get OH and N2 plus and Cl minus. Now with hydrolysis means when you treat it with water, right? Just now we have seen if we treat it with water, this group gets converted to OH. So that is why the correct answer for this question will be option number A. Okay. Next, which one of the following is not the correct reaction of aryl diazonium chloride? Okay. So if you see the first one, with Cu2Cl2, it will give you chlorobenzene. This is correct, right? This is which reaction? Sandmeyer reaction. Now if you see next one, with HbF4, it will give you fluorobenzene. This is also correct. Now with with SnCl2HCl, it gets converted to NH2. Reduction happens. This is also correct. But this reaction, H3PO2 giving you PO4, this one is wrong. Now in this case, what happens? If this one reacts with H3PO2, we get benzene. The product formed here is benzene, not phosphate group is not attached. So which of this reaction is incorrect? That is your option number C. Okay, here the options are little arranged in a different way, but the correct answer is this one. Okay. Next, third question, the product of this reaction. So this is question number 3. Product of the reaction. So this is a coupling reaction, right? So what will happen? It is written in a different way. How we have practiced? See, you have like this. This is N triple bond N plus Cl minus, and this side you have OH group, right? So HCl will be removed. So what we will get here, a double bond N and here OH. So that is your para-hydroxy azobenzene. Right? Clear? Fine. Next, coming to question number 4. The reaction of benzene diazonium chloride with aniline yields a yellow color dye. Right? We have just seen there are two coupling reactions. One is orange dye, another is yellow dye. The name of the yellow dye is, so it is para-amino azobenzene. Right? So how the reaction looks? So if we draw the reaction, so it is like this. You have here N, triple bond N plus Cl minus, and then you have here this one, here you have aniline, okay, and here H. So this part is removed, so we get a compound like this where you have N, double bond N, and then you have NH2, right? So the name of this compound is para-amino azobenzene. Okay, so this one is yellow in color. Okay, so correct answer for this question will be option number B. Next, okay, again you have to find the reaction here. So first one, NH2 to N2 plus Cl minus, that is the formation of benzene diazonium chloride. For this we need nitrous acid. So I told you many a times it will be written either NaNO2 dilute HCl. Here it is concentrated HCl, so we can remove this option. This can be there, this can be there. Next, to get N2 plus and BF4, so here we need HBF4. Right? So this will be H plus, this will be BF4 minus, so N2 plus and BF4 minus salt will form. So we need HBF4. Here BF3 is given, here F2 is given, so we can eliminate these two options. Correct answer will be option number A. Now once you get this one, if you to get nitro group, just now we discussed in the reaction, it is copper with NaNO2, right? So this one will give you, so correct answer is option number A. Okay. Fine. Next question, which of the following will be the most stable Dizonium salt? So if you draw the structure of Dizonium salt, we have like this. So one second. Okay. So for example, this is the structure of benzene Dizonium chloride. Okay. Benzene Dizonium chloride we have. Now if you see, this is a positive charge, right? So if electrons, it can gain electrons, then it will be more stable. So if you see, if you have C6H5, okay, then there will be resonance from here and this one will get stabilized. So the most stable one is your option number B. Okay, fine. So this is a homework question now. The correct sequence of reactions to be performed to convert benzene into metabromoaniline. So you have to convert benzene to metabromoaniline. That means we have bromine and you have NH2 in the meta position. Okay. So what can be the correct order of converting this, what can be the correct process to make this conversion, that you have to think. Okay. So yes students, we have come to an end of this lecture today, and with this we have completed amines chapter, and with this the 4 important organic chapters are completed. Okay, so I hope you are enjoying this session, and if you are liking this session, please do not forget to subscribe the channel, and we'll be coming now, we'll be doing the next biomolecules chapter, and after that we'll practicing PU1 topics also. So this series will be covering the complete KCET syllabus, so please do not forget to subscribe the channel, and do not forget to join the WhatsApp channel so that you can get access to all these notes. And one more thing, do not forget to comment down the homework answer. Okay, so yes, see you in the next class. We'll starting a new chapter, that is biomolecules, and stay tuned. Then I will tell one more thing, that all the very best for your KCET 2025 preparation. Please do not forget the target. The target is 60 out of 60. Okay, thank you and see you soon in the next class.